A literal equation is an equation with more than one variable, and you'll often see that with formulas that you're familiar with. For example, the area formula for a triangle, area is equal to 1/2 base times height. You can see we have more than one variable in it. We actually have three here, don't we? There are occasions when we might want to solve, rather than having A equals, we might rather have it solved for H and say that H is equal to and then some expression. We might be wanting to figure out the height over and over again given the area and the base. In order to solve a literal equation, they're all going to be a little bit different, but I'll give some general instructions. First, you want to observe where the variable is that you're wanting to solve for, and then move all terms with that variable to one side of the equation if necessary. And then, if necessary again, if you're going to need to move all the terms that don't have that variable in it to the other side of the equation. And then you're going to do some steps using a reverse PEMDAS to isolate the variable, sometimes by multiplying or dividing. We're not going to be doing any factoring on our problem, but yes, factoring if necessary. So let's start with example 1. Solve the following equations for A. So this is telling us what we want to solve for. I want to observe where the A is in my equation. There it is on the left side. So I want to have my A variables on one side, my A term, so this is an A term, and I want to move my other term, my minus x, to the right side. So to do it, I'm going to add x to both sides. So I end up with 1/4 AB squared is equal to C plus x, which we can't combine because they're not like terms. All right, so now we need to continue. We need to continue going and get this A alone. So we have to undo the numbers that are attached to it. I like to get rid of my fractions first. So I'm going to come in and I'm going to multiply both sides by 4. So I'm going to take my right side, multiply it by 4, and that's my left side, isn't it? And then my right side and multiply it by 4 as well. And so when I multiply the left side by 4, those are going to cancel, and I'm going to be left with AB to the second is equal to, and I'm going to choose to distribute this. On these problems, there is not a right or wrong way often to do it. So if you chose to leave the 4 out front, it would still be okay as well. My last step in wanting to isolate my A, I still have the B squared attached here, is I want to undo this. So since it is multiplied on, to undo it, I'm going to divide by that B squared, and I'm going to divide the whole side by B squared. So then that's going to, again, cancel, and that's going to leave me that A is equal to 4C plus 4X, all divided by B squared. And that's my answer on that. B, we'll do this one. Again, we're solving for A, and I want to locate my A's. Here's an A. Oh, there's an A on this side as well right there. So I want to get my A's on the same side, so I'm going to move them to the left. So I'm going to have to plus this A to get it off of this side, and I have to do the same thing over here. Oops, it's just one A. So I'm adding this A to both sides, and when I do, this comes out to be 0, and over here I have 2A plus 1A is 3A. Then minus 3B plus C equals 2D. All right, so I've got my A terms on one side. I need to get my other terms to the right side, so get them off. So I'm going to undo a minus, I'm going to add, so the 3B to both sides, and I'm going to subtract the C at the same time. So I'm going to be left with then, these are going to be gone, 3A is equal to D plus 3b minus c. All right, so one last thing to do. The a still has a coefficient, and the last thing I'm going to have to do is I need to divide both sides by that 3 to eliminate it from the a side. So I get a is equal to d plus 3b minus c all over 3. I'm going to stop now and I'm going to pick up on the next video with the next problem.